A very good afternoon, class. I hope you all have gone through the video which I had sent yesterday because in that I taught you all what we will be starting from today. So, yesterday, class, we learned what is the meaning of assignment. It is one of the techniques which is used in the optimization problems to help us derive the best possible solution, the best optimal solution by assigning jobs to different people on one-to-one basis. So as you all saw class yesterday, we stopped on this particular slide wherein we discussed that in order to find out the best optimal solution, we can't solve all the problems by calculating n factorial ways because this is very time consuming. So there is a need to calculate. There is a technique which should be efficient and computational enough so that we can derive the best possible solution to the problem given. So class, the problem which we'll be studying about today is called as the Hungarian method or the Hungarian technique. Now class, why is the name given so? This method was developed in 1955 by Harold Kuhn. As the algorithm was largely based on earlier works of two Hungarian methodologists, Denis Koenig and Zeno Egervary, that is why the technique is being kept as the name Hungarian method, because Mr. Harold was in the first one who followed and used this technique in finding out the best optimal solution for a given problem. So let's have a look how it helps in finding the optimum solution for assigning jobs in case of large assignment. So here we start with the Hungarian method. Now class, before I move on to for the further topic, just pay attention to this particular slide. Today, total there are two categories of sums which are covered in your syllabus. One is on minimization and the other maximization. As you all know class, we saw that optimization problems deals with two objective functions, either minimization or maximization. Our problems today will be focused on category 1, that is minimization. So we'll be learning how to solve sums based on the objective function minimization, and in that I'll be teaching you all two types of sum. One will be a balanced problem and the second will be an unbalanced problem. Now let's move on to the example so that you can understand how to solve a particular balanced and minimized problem. Now this is a problem which is given in your textbook. A departmental store has 4 workers to pack their goods. The time in minutes required for each worker to complete the packing per item sold is given below. How should the manager of the store assign the jobs to the workers so as to minimize the total time of packaging? So this is your assignment technique. As we saw, it is given in the format of a matrix, n into n, that is rows multiplied by columns. Class, there's a small printing mistake over here. Instead of 0, the number is 3. So when I'll be solving the problem, just pay attention that the first number wasn't 0, it was 3. So class, we are starting with the sum. So pay attention when I'm teaching. Before we start with the sum, there are some basic common checking before you start your sum. So whenever you see any problem, whether minimization or maximization, first you have to see whether these two conditions are satisfied or not. The very first condition is you should always check whether your rows and columns are equal. As you all paid attention, our first example is based on balanced and minimization problem. So balance means when your number of rows is equal to your number of columns, the particular problem can be defined as a balanced problem. What is the objective function? Now class, you're familiar with this topic, objective function. It is nothing but the final answer, the best optimal solution we are trying to find out. It can be either to minimize your resource or maximize your profit. So whenever you start with any kind of sum, always do these two basic checking. So what you will check class, the rows should be equal to columns, and second, what is the objective function, either minimization or maximization. So moving forward with the same sum. As I told you class, the first number here is not 0 but 3. So how to solve the sum? So applying the same condition here, as I told you class, y'all can see there are 4 rows of workers, that is A, B, C and D. And there are 4 columns of the packing items, that is books, toys, crockery and cutlery. So class, my first condition is satisfied, that is the rows is equal to column. So I can say that my problem is a balanced one. Second, the objective function which is specified is to minimize the total time of packing. So my second basic checking was my objective function. So I have to find the best optimal solution that will help me to minimize my total time of packaging. So let us see class how to start the solution. Now in order to start the solution by Hungarian method, the very first step is to identify and do row minimization. Correct. Now as you can see class, I have underlined all the small elements in specific rows. So your first step will be to find out the smallest elements in all the rows, which is called as row minimization. So in the first row, you can see the minimum number was 3 and not 0. In B, you have 2 times 2. In the row C, you have 1. And in the row D, you have 2 times 4. After finding out the minimum numbers, you have to subtract them from their respective elements of the rows. That is, you have to subtract 3 from all the 4 numbers in the first row. So 3 minus 3, 11 minus 3, 10 minus 3 and 8 minus 3. So here comes the solution. Converting in row minimization. So your matrix will look somewhat like this. 3 minus 3 gives you a 0. 11 minus 3 gives you 8. 10 minus 3 gives you 7. And 8 minus 3 gives you 5. Similarly, 13 minus 2 gives you 11. 2 minus 2 gives you a 0. 12 minus 2 gives you a 10. And again 2 minus 2 gives you 0. So in this way, you have to minimize all the row elements. I repeat, the row elements are nothing but the horizontal lines as you can see, or in simple words, the sleeping lines which you can see over here. In this way, you got your first step, that is converting in row minimization. Moving on to step number 2. Now in step 2, after rows, you have to underline all the minimum numbers in specific columns. As you can see, I have underlined all the minimum numbers in specific columns, that is books, toys, crockery and cutlery. And in all the above row columns, you can see the minimum number is none other than 0. So here comes our step number 2, converting in column minimization. So the column minimization will be the same elements because anything subtracted from 0 gives you the same number. So 0 minus 0 gives me a 0. 11 minus 0 gives me 11. 2 minus 0 gives me 2. And 0 minus 0 again gives me 0. In the same way, I have completed all the column elements, which is nothing but the same as the row minimization elements. So I hope class, the first 2 steps are clear. So after checking the basic 2 things, the first step is identify the smallest number in the rows and subtract it. Then identify the smallest number in the columns and subtract it. Before we move on to the next step, please check in the column minimization step that every row and every column should have at least one zero. There is no problem if there are more than one zeros or all the elements are zero. The requirement is at least there should be one zero in every row and every columns. Moving on to the third step. Once you are satisfied with getting all the zeros in rows and columns, we move on to the third step, that is drawing the required lines. Now pay attention class how to draw a line. While drawing the lines, you have to start from the row containing maximum zeros. So pay attention class, always start from the rows first. So in my first row A, you can see there is only one zero. In my second row B, I have two zeros. In my third row, again, I've got only one zero. And in my fourth row, again, I've got two zeros. So as you can see, there is a tie between row B and row D. So first, I will draw the lines on row B and row D. Drawing the lines are compulsory and you will do this with your pencils. After completing the maximum rows, we will move on to the maximum columns. Remember class, you have to go alternate. One row, one column. One time full rows, one time full columns. So as the maximum rows are finished, we are moving on to the maximum columns. Those zeros which are cancelled will not be counted again. So when I'm seeing the columns class, in column books, I've got one zero. There is no zeros in toys. There is no zero in the column of crockery. But there is a single zero again in the column of cutlery. As you can see class, there is a tie again in the columns books and cutlery. So the next lines which I'll be drawing will be in these two columns. Now if you observe class, all the zeros are completed. All the zeros are covered completely with the lines. Before you'll draw the lines and after you'll draw the lines, you have to check that you have left out no zero anywhere, either in rows or in columns. Now, what will be the fourth step? As the number of lines are equal to the number of rows and columns, we will allocate the jobs. So as you all saw, we had 4 rows and we had 4 columns. The lines which we drew are also 4. So when the number of lines are equal to the number of rows and columns, we can allocate the jobs, we can distribute the jobs as follows. Now, what is the technique when you all distribute the jobs? While drawing lines, we used to see which row or column had the maximum zeros. While allocating the jobs, you have to see which row has got only a single zero. So your allocation will start with only one zero. Again, the trick is you have to go through rows first. So as you can see, in row A, I have got one zero. In row B, you have two zeros. In row C, you have one zero. In row D, you have two zeros. Now how to start the allocation? I will start the allocation with the rows having 1 0. So the first box, the first allocation I will give will be to box A, row A, because it has got only 1 0 in its row. Now class, when you put the box in the 0, the column in that, if there is any 0, that 0 will be cancelled like this. So basically, when you are going row wise, you have to see that it should have only 1 0. Then you have to put it in a box. Once you put it in a box, the specified column, that particular column, all the zeros will be cancelled. If you all didn't follow, don't worry. Keep paying attention. In row B, we have two zeros. So for the time being, we will not allocate any jobs over there. We will leave that row. We will move forward to row C. Again, class, you saw that there is only one zero. So I will first put a box over there. When I put a box in that row, all the zeros of that column will get cancelled like this. Moving on to the row D. Now, as you'll see, class, there were two zeros in D. Out of those two, one I've already cancelled. So I am left with only one zero, which I'll put in a box. Now, in this particular column, there is no zeros, so there will be no cancellation. So, class, as you all saw, all the rows are over. Coming after rows are over, our next step is to do the allocation column wise. In the first column, there is already a job assigned, so we will not do it again. In the second column, as you can see, class, there is a single zero left. So whenever we see a single zero, we can put it in a box. Now, when you all are going column wise, you have to see that in this specific row, all the other zeros should be cancelled, just like this. In the crockery column, as you see, there's already a box aligned. And in the column of cutlery, there is also a job assigned. So we had 4 workers, we had 4 jobs. So class, what is the conclusion? Every worker has a job and no job is repeated. So finally, coming towards the end of the sum, you have to draw a table like this. Workers ABCD and the jobs which are assigned to them. A was given the assignment of books packing. B was given the assignment of toys packing. C was given the job of cutlery packing. And D is given a job of crockery packing. So finally, we are doing the sum to find out the minimum cost time. This was the main question. This is the final answer which we derived. So class, how will we find the final answer? That is the total minimum time. So this is one of the easiest steps. The boxes which you have assigned, you have to remove the time which was given in the question. That is, as you can see, A is assigned the first row and first column. So the time given here was not 0 but 3. B is assigned the job which is given in the second row and second column. The second row and second column has the number 2. Similarly for C, he is given third row, fourth column. So the number is 1. And as far as D is concerned, fourth row, third column, the times given is 4. So we'll be adding up all the 4 timings of all these workers. So which is 3 plus 2 plus 1 plus 4, which is equal to 10 minutes. So if we assign the job in this particular order, our work will be done in 10 minutes. So I hope class the first sum is clear to you all. If not, no worries, we are moving on to the second sum, so pay attention. This is a sum from your exercise 7.1. A job production unit has 4 jobs A, B, C, D, which is manufactured on 4 machines P, Q, R, and S. The processing cost of each job for each machine is given in the following table. Find the optimal assignment to minimize the total processing cost. So class, as I told you, before we start, always check the 2 basic conditions. The first one was the rows should be equal to columns. So can you see you have 4 rows, PQRS, and you have 4 columns, 1, 2, 3, and 4. So my first condition is satisfied. Moving on to the second condition, my objective function. So the objective function which I will be finding is to minimize the total processing cost. So let us see, my 2 basic conditions are satisfied. So I'll start with the step number 1, which is to identify minimum numbers from each row. So here the minimum number in the first row will be 25. In the second, it will be 21. In the third, it will be 19. And in fourth, it will be 34. Correct. So this is how my first step will be done. Converting in row minimization. This will be the matrix which you will obtain after subtracting all the minimum elements from their respective rows. Moving on to the second step, that is converting in column minimization. Now in every column, I have to identify the minimum number. So in the first column, the minimum number will be 0. In the second, again, it will be 0. In third, again, it will be 0. And in fourth, again, it will be a 0. So this will be my column minimization matrix. After subtracting 0 from all the numbers, I'll get the same numbers in the columns. Before I move forward, I should check that I have at least one 0 in every row as well as in every column. So I have checked and there is at least one 0 in each row and each column. The third step is to draw the required lines. Does anyone remember what was the technique I taught you all? In order to draw the lines, you have to check which row has got the maximum zeros. So first we'll start with the first row having 1 0. In the second, there is again 1 0. In third, there is again 1 0. And in fourth, there is again only 1 0. So all the rows are having 1 1 zeros each. So that means there is a tie in all the 4 rows together. So I will draw the lines like this. Now as there is a tie, there will be no column drawings in this particular case. Once I have got all the lines, what I have to check? Whether all my lines are equal to the rows and columns. What is your observation, class? As the number of lines is equal to the number of rows and columns, we can allocate the jobs as below. So as the number of lines are equal, I can start assigning the jobs. What was the trick? Do you all remember? Correct. The trick was go row wise and see where you can see 1 0. So in the first row, I can see a 0. So I'll put my first box over there. When I put a box over there, in that particular column, if there is any 0, I should cancel it first. But in this case, there is no 0 left. In the second row, as you can see, there is again 1 0. So I should put a box over there. Again in that column, there are no extra zeros which I should cancel. In the third row, as you can see, again I'm left with 1 0, which I think I'll put it in a box. Similarly, I am left with the fourth one and I'll put a box like this. So in this way, each person is assigned one particular job. So the final answer will look like this. The job was P was given machine second, Q was given machine 4, R was given machine 1, and S the third machine. So how will you remove your objective function, that is minimizing the total cost? This was your original question. This is what you got the answer to be as. So you will find the answer by adding all the 4 costs together. So the first cost will be 25 plus 21 plus 19 plus 34. So the total minimum cost which you get is rupees 99. If you follow this particular order, you will reduce your cost and it will cost you per item rupees 99. So these are the sums based on category 1 minimization which are balanced. We are moving forward with the next heading, that is second example of category 1. Now we'll be seeing sums which are unbalanced. Now, what do you mean by unbalanced? Balance means rows are equal to columns. So unbalanced means here your rows won't be equal to the number of columns. So what you will do and how you will solve them by Hungarian method. Let's have a look. Observe the question very carefully. Now as you can see, the very first thing is you have to check that the rows should be equal to the columns. What is your observation over here, class? Here you can see there are only 3 rows, A, B and C. But there are 4 columns, M1, M2, M3, M4. That means we are missing a fourth row B. So class, whenever your sums are not balanced, you can make them balanced by adding a dummy. Correct. Dummy refers to a row or a column in which all the numbers are 0. In this case, we are short of with the 4th row. So I am adding a dummy row D. In the same way, if there was no M4 in the sum, you could have added a dummy column. So the matrix will be formed like this. The dummy row has all the numbers to be 0. Checking the second basic thing. What is my objective? To minimize the total man hours. So I have to minimize my total time in hours. So again, this will be the first step when your problem is unbalanced. So you have to add the dummy by putting all the elements as 0. Now you know what is your next step. You have to identify all the minimum numbers in all the rows. In this case, it will be 2, 3, 3 and zeros. So with this, you get your second step, that is you will convert it in row minimization. So the matrix which you will get will look like this. After that, step 3 will be converting in column minimization. So for column minimization, you have to find out minimum numbers from each column, which sums up to 0. There are 2 zeros in the first column, 2 zeros in the second column, 2 zeros in the third column, 1 zero in the fourth column. So after subtracting the numbers, you will get a matrix like this. Before I move forward, I should check that whether I have at least 1 zero in each row and each column. Just satisfied. So moving on to the next step is draw the required lines. Now can anyone tell me or remember what was the technique I taught you? In the first row, you have 1 0. In the second row, you have 1 0. In the third row, again you have 1 0. But in the fourth row, you have got 4 zeros. So which is the maximum rows with zeros? The fourth one. So the first line will be drawn on the fourth row. Now all the rows are finished. We will move forward to draw the lines column-wise now. In the first column, we see that there is only a single zero. In the second, again there is a single zero. In the third, again I have only 1 0. And in fourth, there are no zeros left. So class, there is a tie in first, second and third columns. So the lines will be drawn like this. Now what is your conclusion, class? All the zeros are covered. But what about the lines? Are they equal to the rows and columns or not? So what's your conclusion? As the number of lines is equal to the number of rows and columns, we allocate the jobs as below. So this was the matrix which we derived. Now how to draw the zero? Do you remember? You should have only 1 0 in each row. So the first row has got a 0, so I'll put that in a box. But what about this 0 in that column? Correct. You will cancel that 0. Coming to the second one, we'll put a box over there as there was only one zero. But what will happen to the zero in that column? Nothing. You will cancel it. Coming to the third row, again there's a zero. I'll put a box over there. And the zero in that particular column will be cancelled. And in D, you are left with only one zero, which will be put in a box. There's no zero to cancel in that particular column. So in this way, class, you got one particular job for one particular person. So what will be the conclusion? So job A will be assigned to men, B 1, C 3, and D 4. This was your original question, including the dummy row, don't forget. And this was the answer which you derived and you got it. So as you all know, our objective was to minimize the total man hours. So we'll be adding up the hours to see how much time is the total optimum time or the best time. The answer will be 2 plus 3 plus 3 plus a 0. Your final answer will be 8 hours. This will be the optimum or the best time if you go with the assignment you got with the help of Hungarian method. So I hope you are understanding how to do the sum. So class, I want you all to practice all the 3 sums again. And if any doubt, please let me know. In tomorrow's session, we will be covering some other types of minimization problems. Till then, stay safe, take care, keep learning, keep studying. Thank you so much.